All right, our next lesson is 2.2, the addition and multiplication properties of equality. It's a little bit longer because I do want to cover quite a few examples. This is really, in my mind, one of the most important lessons because it really gets into the what you're going to see a lot of in algebra. And again, I would tell you guys, please review the PowerPoint that goes along with this first, as I, again, go with the assumption that that's what you did do. And this is a really important slide here. Okay, and why it's important because it shows you what you do to solve these equations and what it is, when we talk about opposite or inverse operation. So you'll hear me say that a lot, especially in this lesson and kind of going forward. We don't, at least right now, we're not going to work too much with the square root, but eventually we do get to that. And we do touch some on these fractions, okay? But the way you undo or the inverse operation of addition, so if you had n plus 5 and you needed to do the inverse operation of that, is to subtract 5. We talk about the opposite of operation. So y minus 17, you would have to, if you want to do the opposite operation of that, is to add 17 to both sides. This would be multiplication. So to undo 4 times h, you divide 4 to both sides. And then if something's being divided, to undo that, you would multiply. Okay, so these are really, and really these first 2, maybe 3 are really what you're going to see a lot of in this lesson right now. Maybe, I'm not sure if we touch on division too much. And actually you do have a couple that deal with the fraction. And I'm actually looking, we do have a division. So we're probably going to touch on all of these. And how you undo a fraction. The way this is written, I don't want to get into it too much, but we'll do an example that shows this a little bit better. All right, so let's look at some examples. So normally you're not going to see the constant in front of the variable, but what you always want to do is you always want to end up with a variable by itself. In other words, I just want x by itself equals a number. So really you're asking yourself, what would I add? I had 7 and it's added to a number. What is going to make that -5? And you may be able to come with that answer just by looking at it. What we want to do is solve it algebraically. And the way you do that is you're trying to just isolate that variable x. All right, so in other words, I need to get rid of that 7. That is a positive 7. So if you remember the previous PowerPoint slide, what you do is what we call the opposite of it, or the inverse operation of +7. The inverse operation of +7 would be to -7. So if I had 7 and I took away 7, the 7s would be gone, okay, and I would just be left with x. What is important, though, to remember is whatever I do to one side, okay, I have to do the same operation to the other side. When we talk about sides, we're talking about sides of the equation. There's 2 sides to the equation. So I'm doing a -5, take away 7, and that's going to give me a -12. And I will tell you guys, in a lot of these problems, you should always know if the answer is right, because all you have to do is just plug in that value. Okay, so if you wanted to check that, if I go 7 plus 12 negative, I should get, that's how I know that this is correct, okay? And I think in the PowerPoint, it talks a lot about checking your answers, all right? In that homework, since you're gonna have unlimited limited opportunities on these problems, I don't mind so much, but on your test, you probably do want to check. And some of them are really like, this is a very easy check. Some of them are a little more there's a little more to those checks. Another example. All right, so remember, we always want to isolate these variables. Well, what you see is there's variables on both sides of the equation. And this is where you can eliminate whichever one you want. If I wanted to, I could subtract 3x to both sides, okay, to get rid of the 3x, get all the variables over here. But the easier thing to do would be to get rid of the 2x, okay, by subtracting 2x to both sides. Because if I do that, I'm just going to be left with 1x, and that's basically what I want, because I want that x by itself. So again, what I want to do is, and I got to subtract the whole negative 2x, not negative 2, negative 2x, because now this eliminates the 2x. I got all my variables on the same side. I'm not touching the negative 4. The negative 4 just comes down. Okay, these cancel out, and 3x minus 2x would give me 1x, or just x. Again, you could kind of hard check. 3 times negative 4 gives me negative 12. 2 times negative 4 would give me a negative 8, take away 4, which would also give me negative 12. So I'd have the same value on both sides. We know that that answer is going to work. All right, next example. Or x plus x minus 5 equals 4x plus 4. All right, so what you want to do, even before we start trying to eliminate or get all the variables on the same side, you'll notice on this left side here, this is not simplified. So the first thing you always want to do, in this case, everything was simplified on each side, okay, on the first two examples. So what you want to do before we really start doing too much is to simplify this. In other words, I have like terms here. I got that 4x and that x there. We know that that is a 1x, right? So I want to combine those first. 4x plus 1x would give me 5x. So I got a 5x minus 5, 4x plus 4. The only thing really I did was just add these two terms together, okay, before I start doing anything else. And now we're going to solve this algebraically. Before I start removing these constants or getting all the constants on the same side, I need all the variables. You want all the variables on one side, all my constants on the other side. All right, and again, I can get rid of whichever one I wanted. It's a lot easier if I just get rid of that. Because if I did subtract 5x, I'm going to have a negative 1x over here. And I don't really, if I can avoid getting a negative 1x instead of having a positive, I'd rather have that positive 1x. So my first step would be I want to move all my variables on one side. And I'm just moving down my constants. So what happens here with the 4x minus 4x, these are gone, right? So I'm left with 4 on that side. And here, 5x take away 4 would give me x. So I'm going to have x minus 5 equals 4. 4 just moved down, and minus 5 just came down. Again, when you move it down, make sure you bring that minus with it. Okay, and 5 take away 4 gives me that 1x, but I don't need the 1 in front of it. All right, so that was my first step. I just have one step left. I got to get rid of that minus 5. So the inverse operation, or the opposite of minus 5, would be plus 5. Again, whatever you do to one side, you must do to the other side. My x comes down. These 5s cancel. And 4 plus 5 would give me 9. A little more complicated check, but it's still possible if you wanted to do that. Some more examples. Just a quick kind of point to make. 2.1 was dealing with simplifying expressions, okay? And you'll notice I got to simplify this expression first before I could solve the equation. The difference between an expression and an equality is the equal sign, okay? So when you see an expression, you're just simplifying, there's not an equal sign. When you see the equality and there's an equal sign, basically, you know you're gonna have to solve for x. Where one you're just simplifying, the other one you're actually solving. You wanna know what is the value of x. So if you look here, we will have to simplify this side of the equality before I can solve it. Okay, there's not much going on over here. This is just 14. But anytime, and that's what I kind of was talking about with 2.1, anytime you see that a distributive operation needs to be done, that's always going to be that first step that you're going to want to do. So in other words, I got to distribute that -3 into this equation because I'm going to have some like terms that I'm going to have to clean up a little bit. This is going to be -3x minus 3 plus 4x equals 14. All right. So again, not much going on over here, but I'm not done on this side. I have like terms. So hopefully we remember from our 2.1. I have to combine -3x and 4x. So in other words, you have to simplify each side of the equation before we start inverse operations. So we really start isolating the variable and all that stuff. So -3 plus 4x is actually going to give me a 1x. And again, when it's 1, we don't really write a 1x, we just write x. I'm going to move down to -3. I haven't touched that -3. It just comes down. And then I have my 14 on the other side. All right, so once I distribute and I combine my like terms, it's a single step algebra equation. What's the opposite of -3? +3. The x just comes down. The 3's cancel. And 14 plus 3 gives me 17. Okay. And that's kind of like I said, last 2.1, they were just kind of giving you this and you had to simplify it to this point. And then really the only thing that's new now is this equality that you've got to solve for x. Right, another example. All right, so we want x by itself. And you're going to tell me, well, x is already by itself. The reason why it's not is we really want a 1x, okay, a positive one. What is the number that's in front of this x? Okay, we talked about that. That is a -1. So I need to get rid of that -1. I want a positive one. And remember, what's happening if I don't see a plus or a minus in between this? What do I know is going on here? Well, what is going on is it's being multiplied. Anytime you don't see it, you know that that's multiplication. And so I have to undo, or the opposite of multiplication is to divide that by -1. When I divide -1 to -1, I get a +1, or just a positive 1x. What I do to one side, I have to do to the other side. So a -12 divided by -1 would give me a +12. Right, so just keep that in mind when you have that negative. We can't leave that -x in there. Next one we want to look at is fractions. And what you do to get rid of a fraction is you do the reciprocal. Okay, you're going to multiply the reciprocal to both sides. So in other words, you got to take that fraction. If you flipped it around, it would turn into 3/2, right? And when I multiply, then the 3's cancel, the 2's cancel. I'm just left with x. Okay, so I just multiplied it by its reciprocal, and it left me with x. Well, again, what I do to one side, I have to do the same thing to the other side. So I have to multiply this side by 3 over 2 and put a 1 underneath there. Okay, and we multiply straight across. This would give me negative 18 over 2. Negative 18 divided by 2 gives me negative 9. This is an easy check. 2 times negative 9 is negative 18. Negative 18 divided by 3 would give me negative 6. So anytime you see a fraction, to undo it, you multiply by its reciprocal. So what's happening on this problem? You have your A, it's being divided by a negative 9. So I will have to undo the division problem here. Okay, so the opposite of division, again, if you go back to that slide in the beginning of the lesson that we talked about, it's all on there. So if you want to print that out or just kind of have that ready for you to reference it, it'll help you out. The inverse of division is multiplication. So I got to multiply negative 9 to both sides. Negative 9s would cancel. What do I be left with? I'd just be left with A. And then 2 times negative 9 gives me a negative 18. So in that format, it's just a single step algebraic equation. I want to show you some double step algebra equations here. And by double step, I mean it's going to require 2 steps to solve them. All right, so in order to get this x by itself, not only do I have to get rid of that 6, I got to get rid of that negative 4. All right, and what you always want to do is get rid of your constants first, okay? Because to get rid of the 6, remember that's 6 times x, I'm going to have to divide. So I don't want to divide with a constant here. I want to get all my constants on one side first, and then divide, then get rid of that 6. So to get rid of that minus 4, I'm going to have to plus 4 to both sides. And I'm just going to move. 6x comes down. 62 plus 4 would give me a 66. All right, so plus 4 to both sides would be my first step. And then my second step and my last step is to get rid of the 6. To get rid of the 6, I must divide 6 to both sides. 6's cancel out. I'm just going to get x equals 11. All right, 2-step algebra equation. Let's look at another 2-stepper. All right, so again, I got to get rid of the 9. I got to get rid of the plus 2. I don't care what's on this side. Okay, because sometimes people will tell me I got to add 6 to both sides. No, I don't want to get rid of the 9. I don't care what's on this side. I care about what's on the side with the variable. Okay, because I want to isolate the variable. I want that variable by itself. I don't want anything else with it. All right, so I got to deal with the 9 and the 2. First thing I want to deal with is that minus 2. So I got to do the opposite operation of a minus 2. I mean of a plus 2, which is minus 2. Okay, that cancels that out. And that leaves me on that side with just x divided by 9, or x over 9. And then negative 6 take away 2 give me a negative 8. That's my first step. And my second step is to get rid of the 9. Since it's being divided by 9, I have to multiply 9 to cancel those 9s out. And then I have to multiply 9 here to the negative 8. And negative 8 times 9 would give me a negative 72. All right, I think we have about 3 more examples. Next one. Negative 4a plus 32 plus 8a equals 3a minus 7a. All right, so remember, there's two sides of these equations. And you always want to make sure both sides are cleaned up, or in other words, both sides are simplified before I do anything else. So I'm not going to add 4a to both sides because I haven't cleaned this up yet. I have like terms on this side of the equation that I have to clean up. And also I'll have like terms on this side. So remember, so that equal sign kind of splits up the two sides. We want to clean this up first. So negative 4a and 8a would give me a positive 4a. I move the plus 32 over. And then 3a minus 7a gives me a negative 4a. Now be careful. I have a negative here and a positive here. They're not just going to cancel each other out. So again, at this point, I need to get all my variables on the same side. And a lot of times I'm going to move this variable over here. So I want to cancel out that minus 4a. But if I do that, that's going to leave me with the 0 here. It's going to be a little more work. So it's a little easier for me to move this 4a over here. Okay. Because I don't want nothing on one side if I can avoid that. So I'm going to move all my variables over to this right side. So in other words, I am going to get rid of that positive 4a by subtracting 4a. So that gets rid of that. So now I just have 32 on that side. Again, if I subtract 4a on this side of the equation, I have to subtract 4a here as well. And negative 4a take away 4a gives me a negative 8a. And this is just now, I just got one more step to do. Get rid of the negative 8. And that's going to give me negative 4 equals a. And if you don't like the a on that side, then go ahead and switch it around if it makes you feel better. It's the same thing. A equals negative 4. All right, another example. Again, you've had expressions like this before that you had to clean up in 2.1. The only thing that's new is that now we have an equals 18 there. So you can kind of forget about that 18 for now. But the first thing we want to do is clean up this expression. I want to figure out if I have like terms, and if I do, I want to combine them. So I always want to distribute first. Negative 4 times 3x would give me a negative 12x. Negative 4 times 2 gives me a negative 8. And then I'm moving down to plus 13x. At this point, we hope we recognize my like terms. Negative 12 plus 13 would leave me with a 1x, or just x, minus 8. Okay, so I cleaned up this whole mess here to just have it be x minus 8. So let's move, at this point, move that other side over. And now it's a single step algebra equation. I got to get rid of the minus 8. I want that x by itself by adding 8. Move the x down. 18 plus 8 gives me 26. Again, you got to get comfortable with that variable on that right side or left side. It doesn't really matter. Okay, and then once you get it, if it makes you feel better, if you really need to, you can switch it around. Okay, that we know x equals 26. You're probably used to seeing it that way, and then reading it 26 equals x. But it is the same thing. And our last example, I'm not really sure why, but they'll throw in simplify the expression. And remember, when you see expression, we know that we don't have a equal sign. So we're not actually solving for x, we're just simplifying this problem. Again, we had these before with 2.1. You have that negative sign in front of a parentheses. And you're saying, well, what's that number? Hopefully you know that that number is a -1. Okay, and it's a -1 that has to be distributed. And then we'll see if we have any like terms that can be added to that 5x. So -1 times 5x gives me a -5x. And then again, -1 times a -2 is going to give me a +2. All right, so at this point, we're looking for our like terms, and we see these two right here. So we have a -5x and a +5x. So again, if we do -5 plus 5, that would give me 0x, but we don't write that as 0x. We know what's going to happen is they're just going to cross each other out. They're going to cancel each other out. And what are you left with? You're just left with 2. All right, so I did quite a few examples on there. I think 1, 2, 3, 4, 5. I did 12 examples of the 20 problems. So again, you won't get the same exact problems. You may, but for the most part, they'll be a little bit different. But it should help you if you get stuck. And again, I would love encouraging you guys. You always start with the PowerPoint. From the PowerPoint, I would go to the assignment. And then if you need additional assistance once you're in the assignment, then that's when you would want to come to the video with the different examples and try to, hopefully I did one of the examples that maybe you're stuck on. And then if beyond that you need additional help, I am available Mondays from 6 to 7 for my office hours. All right, and that concludes 2.2.